Hi guys, so today we'll be looking at the techniques of magnetic particle testing. We'll do an overview and look at where they apply, how they are used, and just a brief short video on it to give us a general idea. For specific inspection technique where we'll look at all the details, that will be covered in a different video. So today we'll just do an overview on the four techniques for the MPI or MT as we call it. So let's check them out. So we'll be looking at the techniques for magnetic particle testing. So you have basically the type 1, type 2, the fluorescent and the visible. For the fluorescent type, which is regarded as the most sensitive for carrying out magnetic particle testing as compared to visible. The fluorescent, in that case, you are talking about how do you view your results. So in the case of fluorescent, you view with your UV lights. While for the visible technique, you are using your visible light, which is your normal ambient light. The one thing you need to note about these two methods, you need to check for light intensity for both of them. So you don't have to assume that your normal lighting condition is adequate enough for your magnetic particle test. So when you put on your UV lights, you wait for some time, usually between 5 to 10 minutes for the environment to become acclimatized to your UV light. After then, you must check the light intensity to ensure that you are getting the required value. The same applies to your visible lights. You need to ensure that you are getting the right intensity so that if you have to maybe bring in an external lighting, you do that. So under the fluorescent method, you have the dry method and the wet method. So which means you are going to have fluorescent dry and fluorescent wet. So fluorescent dry is one technique, fluorescent wet is one technique. If you go to visible dry is a technique, then visible wet is also a technique. If you combine them together, which means you are going to have wet visible, dry visible, wet fluorescent, and dry fluorescent. People often ask which is the most effective, which is the most sensitive. Normally, it will depend on application. Depends on application. Some applications are suitable for wet visible, some are suitable for dry visible, and so on. But if you take all things being equal, all things being equal, all conditions considered, the wet fluorescence is said to be the most sensitive. But if you consider other factors, some other technique may be more sensitive. So when you talk about aerospace, in aerospace inspection, you don't make use of visible at all. Aerospace inspection for any API, you always make use of the fluorescent. So you're either doing the red fluorescent or the dry fluorescent. So if we look at it, the wet method, in the wet method, you are making use of your wet magnetic ink, which usually you spray as you perform your task. While in your dry visible, you have this kind of a dry powdered magnetic particle that you blow into your test object as we would practicalize and see. Where is it applicable for each of these techniques? For wet visible, mostly your portable NPI that you do in the field, where you can go with your aerosol can, your black and white as the case is. So in the case of visible, what mainly differentiates it from the fluorescent, you are using what we call your contrast paint, which is usually the white paint. So in the visible method, you are making use of your white paint so that it gives you the white background. Some people might ask, can we do wet visible without the white background? Definitely, you can go ahead and do it, but your sensitivity will be very, very, very poor. You may not be able to find the cracks or the very tight indications that you are looking for. So, technique wise, you have to use the contrast paint for your wet visible. So, in the case of fluorescent, in both fluorescent, you don't need to use a contrast paint because the UV light fluoresces, which gives you your contrast. In the case of dry visible, you still don't need a contrast paint because it is dry. Applying a contrast paint is not really necessary. So what gives you the contrast in most cases is your magnetic particle, which is usually colored, so that it gives you that contrast. So for wet visible, you can use it for all application where the wet paint does not have any effect on the area you want to test. In the case of dry particle, we have cases where the surfaces are very, very hot. And if you apply the contrast paint, it's going to be an issue and it dries off and creates all sorts of problems for you. We have cases where you have an ongoing welding process offshore, where probably, let's say you are doing a weld, where you have multiple pass, multiple weld bead. And because of maybe the thickness of the material, cracks are likely to develop during your weld. You might be told that maybe after your root pass, after you weld this root, you'll be told to perform NPI. So that if there is any crack that has developed during the welding process, you are able to pick it out. When in doing NPI in such case, the surface is usually very hot. If you put in your paint will evaporate and it will start producing a charred surface, which ultimately will interfere with your results. So in that case, you can use your dry visible or your dry fluorescent as the case may be. You also have cases whereby maybe I have a surface that is already coated. So it's coated irrespective of the color, and you don't want to take out that coating. In this case, it's light coating, not very thick, because there are cases where you can still do NPI on the surface, but the coating should be less than something of around 25 microns. Any coating thicker than that, you cannot do the NPI on the coated surface. In that case, instead of removing the coating, we can just perform your dry visible or your dry fluorescent NPI on it. Then when you come to your wet fluorescent is similar to your wet visible. The only difference is you don't need the contrast paints. So where your visible, you need two can, your white and the second one, your black particle. In the case of fluorescent, you only just need one can. And that is enough for you to perform the test, which is your fluorescent particle. Then in your dry fluorescent, you are still using your dry particles, but this time, in this case, the metal particle that you are using for the test should have the ability to fluoresce under UV light. So this is just a breakdown of the technique, and let's practicalize it. Now we'll just look at a brief explanation. So this is not a detailed inspection of a detailed demonstration of the MPI methods and the techniques. It's just to show you an overview of it. So for the wet visible, you normally would have your contrast, which is your white. So This is pretty common. Most editing inspectors do that. So if you just spray their white, you spray your white, it gives you the background. Then you bring in your magnet and you put in your black. You put in your black and you are able to determine your crack. So this is pretty straightforward and very common. This is your wet particle uh, MPI technique. When you come to your dry particle, in the case of your dry particle, you don't use your aerosol, so it's not wet, it's dry. Like I told you, for dry surfaces, for hot surfaces, for surfaces where applying paint is going to cause some issues. So you don't have to add contrast. Now, if this is called our buffer bulb, you put the black particle, so you open it, you feed in the magnetic particle, which are usually colored. They are colored red to give it the contrast. So in the case of the dry particle, you just put in your magnet. This is your bulb puffer, so that's why it's called puffer. It puffs. So you shake it and you puff and you puff. When you puff, you are applying your particles. You puff, you puff. When you are done, you blow off the excess particles. You can get an external blower or you can just blow. You blow off. If you look at this, you can see that there is a crack here remaining. You can see a crack here. When you blow, the excess particles will leave. The unwanted particles will leave, and you can see your crack. You can see your crack right here. Because of the contrast, you are able to. Because of the contrast, you are able to see your crack. So this is just a simple demonstration of the dry particle. Is a little bit more. Um, we need to do more arrangement. Check your light, whether your light is okay. Use your feed indicator to check your feed and just do your normal basic checks before you start. But as you can see the crack right here. So this is a dry particle. Pretty simple, not so common, and clients rarely request for it. But when they do, you have to perform it. So you need to get your buffer and then your dry particle. And when you talk about currents, there is the DC half wave current, which is very, very good for your dry particle. This is our normal AC current, which is normally for surface, near surface indication, and AC does not penetrate deeply. But if you use your half wave direct current, you can also get some level of indications that are subsurface. It's going to show. This is the dry and the wet visible. So a recap: wet visible, you need your contrast paint and your magnetic particle. The manufacturers of this are very, so you can see the cover of this is white. The cover of this is black, so it's easier to just identify which is your contrast and which is your black magnetic particle. In the case of this, your magnetic particle is black. So when you have black on a white background, it's easier for you to see your crack. But in this case, you have your red particle. It's easier for you to find your crack. So if you percent, it means we are not using our normal light. We have to make use of our UV light. So we have a UV light here connected. So we'll turn off our normal light. And now we'll allow for 5 to 10 minutes so that one, your eyes will be acclimatized to the environment, then two, so that the UV light can warm up and get to its highest intensity before you start doing your empty test. How do you verify if your intensity is enough? Use your light indicator. That is a separate video entirely on that, but this is just to demonstrate the technique, like I said earlier. So in the case of your fluorescent, instead of having your contrast, you are not going to have your contrast paints because the UV light is already creating that contrast and your magnetic particles have been colored to the magnetic particle produces a greenish yellow indication when exposed to fluorescent light. Apart from your normal surface cleaning and preparation, you don't need to apply any other thing before you put your contrast. So you just straight up application of your fluorescent particles. So you just apply. You apply normally. So if there's an indication, by the time you get it to the UV light, if you check it under the UV light, if there's an indication, you clearly see it. So there's an indication here. You can see there is one indication straight here. So basically that's just it. I did not magnetize for long, and if you wait and follow the process clearly, and if there is any indication, you are clearly going to see it in the UV light. The fluorescent method is very sensitive. You can see this crack at this point. It's very sensitive compared to the visible method. Now, this is the wet fluorescent. In the dry fluorescent, it's still similar to the dry visible. Instead of having your normal red magnetic particles, you'll be having magnetic particle that fluoresce. The same puffer bulb is used, and the same process is followed. You just puff, you blow out excess, you magnetize while you are blowing out the excess, and your indications will come out. So basically, that is just the illustration of the four magnetic particle testing technique. Thank you.